So in this video, I'm working on question 5 from the Spring 2020 test 2. So the question is, so suppose that the results of a poll of likely voters is that 51% intend to vote Dem. You can just ignore the 49% intend to vote Republican, because that just means the probability of a 1, let's say that Dem is 1, is 51%. So the question is asking, what is the smallest sample size that would make us reject the null hypothesis that the probability of voting for them, or saying you intend to vote for them, is 50%. Okay, so how can we do it? So we just say, okay, so we use the normal approximation. So the null hypothesis is that the mean is 0.5 for intending to vote, and the standard deviation is 0.5 divided by square root of n, right? So to compute the p-value, we just say, okay, so what's the probability that x bar would be smaller than 49% times 2? That's our p-value. If we got x bar is 0.49, then we just do what's the probability of getting 49 or less, or 51 or more. So that's 2 times p norm of q, 0.49. So for 1,000, we get this p-value, which says that, you know, that the probability of getting something more extreme than 0.49 is actually pretty large. So what if we try 5,000? That gets to 15%. Try 7,000. That gets to 9%. With 10,000, you get less than 5%. So this would be enough, but we can kind of go and say, well, if it's 9,600, so that's going to be like exactly 5%. So basically, like if your sample size is above 9,600, then this difference of 5149 would be significant at the 5% level.